Hey, let's talk about radiation. Right now there's radiation all around us. In fact, if you were to use a GM tube to measure the amount of radiation in our atmosphere, you get about 0.2 to 0.5 BQ of radiation at all times. Many nuclei are unstable. This means that they have a chance to decay. When a nucleus decays, it releases a radioactive particle that carries kinetic energy. And as it moves through the atmosphere, it ionizes other particles in its path, losing that kinetic energy. When all the kinetic energy is lost, it no longer ionizes and gets absorbed by the substance that it is currently in. There are three main types of nuclear decay. Firstly, let's talk about alpha decay.
So for example, here we have a uranium atom. In terms of alpha radiation, what would happen is that 2 protons and 2 neutrons will be ejected from the atom and we'll be left with an atom of thorium. So if we were to write that down, it would be uranium going to thorium plus an alpha particle.
Since alpha decay has a very significant 2+ charge, it easily ionizes all the other particles in the air. That is why it loses kinetic energy very quickly and is therefore stopped by only a single sheet of paper. Now let's talk about beta decay.
In this example, let's say that this is an unstable carbon-14 atom. In beta decay, what would happen is that a high-speed electron would be ejected from the nucleus when a neutron would decay into a proton. So to write an equation for that, we have the unstable carbon atom, which would turn into a nitrogen atom, plus the beta particle.
Since beta decay is much less ionizing compared to an alpha particle, due to its smaller size and only a single negative charge, it requires multiple meters of air or a single sheet of aluminium in order to be absorbed. Finally, let's talk about gamma decay.
So for this last example, here we have an excited nickel nucleus. This is in terms of gamma radiation, and since gamma radiation is an electromagnetic wave, there's no change to the actual atom itself. So when gamma radiation is emitted like so, we have, in terms of the equation, we have the excited nickel nucleus, which would turn into just, it would still stay a nickel nucleus plus the gamma radiation, and it has no mass and no charge.
Since gamma decay is just an electromagnetic wave, it has no charge and no mass. Therefore, it rarely interacts with the particles around it, and therefore it can never truly be absorbed. But its energy can be greatly reduced by using multiple meters of concrete or multiple centimeters of lead. Let's talk about the dangers of radiation. Since alpha radiation is so highly ionizing, it is very dangerous once it gets inside your body and could cause cancer, but outside of your body, it's basically harmless. Beta decay is moderately ionizing, so it's best to keep your distance both inside and outside of your body. Since gamma decay barely ionizes at all, it has a great chance of causing cancer due to long-term exposure both inside and outside your body. Thanks for watching, and I hope you enjoyed.